this nice quadratic, then I say I want to know what f of negative 2 is. And you can see that where I had the x, now I have a negative 2, and that's instructions to me to go ahead and substitute in on the right hand side. Wherever I see the x, put in a negative 2. And because it's a negative, don't forget, you're going to be well served if you put any negatives inside parentheses. So then I know I'm squaring the entire negative, not just the 2. And then minus 2 times a negative 2 plus 4. And that's for my f of negative 2. I also need to find f of 0 and f of 3. Back to the f of negative 2. If I square negative 2, that's negative 2 times negative 2, so it's a positive 4, times a 6 is 24. And then negative 2 times negative 2 will give me a positive 4, and then I have a positive 4 on the end. And I can keep that notation f of negative 2 on the left-hand side all the way down to the very end. And when I add up, 24 plus 4 is 28, plus 4 more is 32. Now down here, I already show the answer, and it says f of negative 2 is 32 corresponds to what as an ordered pair? And I already know that this negative 2 was what I stuck in for x, so I should put that over here in the x part. Remember, ordered pairs are always in the xy order. And then 32 is my answer, and if I recall from back here, f of x is the same thing as y, so this entire thing we can think of also as a y, and so y equals 32, so 32 is what goes in for my y. So I have negative 2 comma 32 as an ordered pair. And now my next one, f of 0. So I'll use this quadratic again, 6 times the quantity 0 squared minus 2 times 0 plus 4. Now 0 squared is just 0, and times 6 is still 0. Negative 2 times 0, 0 also, and all I have left is a 4. So f of 0 equals 4. And if I want that as an ordered pair, remember this is my x part, so put in the 0 there, and 4 for the y. So there would be an equivalent ordered pair. And my last one is f of 3. I'll start it right here. F of 3 equals 6 times 3 quantity squared minus 2 times 3 plus 4. So then I have f of 3 equals 3 squared is 9 times 6 is 54 minus 2 times 3, that's a negative 6, plus 4. Then f of 3, 54 minus 6 is 48, plus 4 is 52. And the equivalent ordered pair would be 3 for the x and 52 for the y. And there's my two answers for that part. So we can see that if we're given instructions, find f of something, we just plug in the something in the equation we're given for the x's. And then when we have an answer, we can pull out the part in the parentheses, which is what we put in for the x, and stick it in the x part of an ordered pair, and then the entire thing is equivalent to a y, so we can put that part in the y part for the ordered pair. Here we have an application that uses function notation, so we know if it's written in this form that if we graph this, it will be a function, meaning it will pass the vertical line test also. Rocket is fired upward from the ground with an initial velocity of 300 feet per second. Now that 300 is going to show up in our equation right there on the t term. And neglecting air resistance, which means if there's wind or just the resistance of air as something's falling, we're ignoring that. The height of the rocket at any time t, I kind of covered that up, can be described by the polynomial function here. This negative 16t squared is always a falling object, and it represents a parabola, upside down parabola. Find the height of the rocket at each given time. So we just need to worry about this function, and we want where will the rocket be at 2 seconds. So we're looking for p of 2. And remember how we did that a minute ago? We just put 2 in everywhere we see the t because this function has t as its variable. So p is a function of t, and the t here is our 2. So we'll put in a 2, negative 16 times 2, quantity t squared plus 300 times 2. So negative 16 times, this is going to be 2 squared, which is 4. So I have to square it first by order of operations, so I get 4 times negative 16. That's going to give me 64. And because of that negative there, it'll be negative 64. And then 300 times 2 will give me 600. And that's P of 2 equals negative 64 plus 600. And then I can add those two together and I get 536 feet, because we are talking about how high will the rocket be at 2 seconds. So I know the rocket will be 536 feet at 2 seconds. Now to do it for 4 seconds, I think you can go ahead and give that one a try, and I'll show you how I work it. Okay, I'm looking for P of 4 for my function in terms of 4 seconds equals negative 16 times 4 squared plus 300 times 4. So 4 squared is 16, and 16 times 16 is 256, and I have a negative, so negative 256 plus 300 times 4 is 1200. And then that's still P of 4. And when I add those two together, I get P of 4 equals 944 feet. So at 4 seconds, my rocket is now at 944 feet. On this problem, I'm asked to figure out a function and then actually use the function to find how much this person makes on his job. So Sam earns $45 per hour plus a $50 flat fee for plumbing jobs. I need that job. Write a function to determine Sam's income for a job where P of H is the total pay for the job and H is the number of hours he worked. So I know my function should start with P of H, and remember he gets this flat fee, so no matter how much he works at your house, he starts off with $50. And then he can add to it, not like he's trying to of course, but he can add to it by the number of hours that he works. So if he works just 1 hour, it would be $45. If he works 2 hours, I would have to multiply that by the H to find 2 times 45 is 90 plus 50 is going to be $140. So if he has to work 2 hours, that makes sense. Now here's my function then, and I want to use that function to find out his total pay if he worked 7 hours on a job. So I'm looking for P of 7 because 7 is the number of hours and H stands for hours, so I'm looking for P of 7, and now I'm just using my function like I did up here. P of 7 equals 50, his flat rate, plus 45 times 7. So 45 times 7 is 315. I want to add that to the $50 that he gets for walking in your door, and I get $365. So using my function, I can create a function to tell me how much he gets paid for each hour, given that he has a base rate, and then I can figure it out. If I know he worked 7 hours, I can just plug that in and come up with the 365. This is very handy to use these types of equations to find answers for things in real life, like a rocket or how much somebody's going to make. And this one particularly you could figure out on your own without making it into a function, But it's handy to use a function if you're going to use computer applications, because then it calculates it without you having to say, okay, now multiply by 7. You just do it, you put it into